Shivratri today. Guys, meanwhile, I would like to, tell you that you can always put your questions in Q&A. The Q&A would be there for the entire session. Right, so you can place down your queries. We will definitely take each and every query, that is there in the Q&A session. So feel free to raise any question regarding to the topic. Just allow us like 1 more minute so that we can start the session today. Right, so the topic for today is how to implement tree data structures in Python. Right, so we will just start the session in next 30 seconds. All right, here we go. So once again, I would just like to greet everyone who has joined. A very good morning. All right, thank you for being here to attend this Guru class, to know a little more about how you can implement tree data structures in Python. All right, I'll just give you a little brief as to what Unikaksha is, right, and how actually we help candidates to make their career. So basically, we are an online education, platform that helps students and working professionals from different industry, from different segment to upskill themselves in tech career. You can definitely, build your career in IT industry, irrespective to whichever industry you are from. So we help you build your career with the help of our top mentors and our industry vetted curriculum. Right. So far, we have had a positive impact in the career of more than 5,000 plus students. And today with this Guru class, we hope to help you in the same manner. So also, I'll just give you a brief introduction about the experienced mentor who's going to take this particular session today. All right. So we have our one of the best and one of the experienced mentors, Swati Yadav. So if I talk about her, she has overall, 8 years plus of experience in Java, FSD, web development. She's also, 2 years of experience as a certified trainer in Java, in web, Python, data science. So she's handled classroom delivery and curriculum development for K-12 segment for web and Python. Right, and Java FSD curriculum development and training for working professionals. So she have actually her expertise in training, and she's one of the best we have that's going to take this session today. So I give you a very warm welcome, Swati.
Hi, good morning, everyone. And Mahashivratri, right? So, hi. So yes. I see a couple of them are still joining, right?
Yes, Swati, we have a lot of people who just joined, in just last 2 minutes. So if we want, we can wait for another like 2 minutes and then start the session.
Yeah, I think that would be great because I see a lot of them, kind of coming up.
All right. So would you want to interact with these candidates meanwhile?
Sure. So what about, as today, everyone know that we have a topic as, tree data structure in Python. And I suppose if you guys are here, you might have a little bit of, information about data structures. What is a data structure, anyone? You can write it down in chat and Q&A as well. I mean, like you need to know, right? That what is data structure? No idea? Anyone else? What do we understand by data structure? Storing data. Okay, cool. And guys, put up your answers over there. I mean, like, it's no one's taking a test, right? So data structure is a way to store and organize data, right? There is so much of data which is there. I mean, like, you're doing application development, you're making products, you are maybe making a web application. So what do you think? Any application is without any data? There has to be some data, right? You talk about a banking, a product, maybe you're making a loan management system. I'm giving an idea, you're making a loan management system. Now, what kind of data would be there in a loan management system? You'll have customers, you'll have loan details, you'll have loan types. These are all, different, maybe the tenure for the loans, different types of loans that are there, home loan, kind of, and so on, the study loan that we have. So these are all data. Now, these data need to be kept somewhere, based on what a customer, what kind of a customer is there. There is a customer, there is a, someone who's come to take loan. You need to keep their details. Once that has been processed and is okay to be provided with loans, then you have to process some other details on that. And that record of data needs to be maintained somewhere. That needs to be organized and maintained, right? So data structure is nothing, kind of, but it's a very important part of any application, any product that you're going to be making or that you're ever going to be working on. Okay. It indicates that the way how the data needs to be organized and stored in the memory. Okay. So there are many ways of organizing the data. So there are many ways in which you can organize data in the memory. Like if you're aware of programming, you might have seen arrays. If you're okay with Python, you might be knowing, tuples, list, dictionary, and so on, right? These are also ways of, kind of storing data. But there comes different kind of data structures also, which provides you more with more set of functionalities and, a good way, you could say, a more efficient way of storage of data. Okay. Now, moving back to, I think, today's topic, which is how to implement tree data structures in Python. Now, let's first understand that Python is a very rich language. There is so much that you can do in Python. With just Python, you can build web application, desktop application, normal mobile applications. You can even do data science. You can do web scraping. There is so much. You can even make, games with Pygame and stuff, right? And there is so much of the things that is possible just with this, kind of very important language that we have, right? And it has a lot of inbuilt functions which are given. And what are inbuilt functions? What are inbuilt functions in any programming language? Anyone? What is an inbuilt function? Main. Okay. I'm asking about, I'm not asking examples. I'm asking about the definition of it. What is an inbuilt function? Okay, so the inbuilt functions are those which are given by the programming language. Yeah, those are given by the programming language, right? So the developers of the language, they've created a set of libraries, in that they have these functions already created for us to use. Okay, so you do not have to write the whole code for that. For example, a very example is init. You have init here. You have length functions. There are different functions for strings, for arrays, and so on, right? And those are inbuilt functions. Inbuilt means they're already given to us by the language, been done by some other developers, the developers of the language, and we are just making use of that to make our life easier and to work on. Okay, those are inbuilt functions. And there are a lot of inbuilt functions in Python, and there are inbuilt data structures also in Python, which what are those data structures in Python? The inbuilt one. Anyone? So in Python, you have dictionaries, list, tuple, set, frozen set, etc. Right? And apart from that, you can also create your own custom data structures, with the help of classes. We also have this OOPS concept in Python, right? And with the help of OOPS concept, with the help of OOPS and classes, you can create your own custom data structures. Okay. Now here in our today's session, we are going to discuss about, data structure, tree data structure. What do we understand by it? Okay. What do we understand by it? So what is a tree data structure, anyone? Or what do you maybe like kind of make out of it? I don't say that you need to provide a correct answer, but what do you think when you hear about a tree data structure? It looks like a tree. Okay. Yeah, but that's a valid point. Yes. So a tree data structure, just no parent. Okay. It contains child. Very nice. So a tree data structure, you see, these are non-linear data structures. Now, if you might are aware of that there are two kinds of data structures that we have, linear and non-linear. Tree falls in the category of non-linear. If you might have heard of arrays, stacks, queues, linked lists, those are linear data structure. Trees and graphs, those are non-linear data structures. So trees, they are non-linear data structures, which represents that there are some nodes which are connected by edges, and each tree, it consists of a root. Let me show you. Okay, something like this. A representation would something like come like this. These are just 5 elements that I have in a tree. And you'll see that there are nodes. Okay, the elements, those are nodes. Those nodes, they are connected by, what do you see over here is an edge, right? The arrow, that is an edge which connects the nodes. You have a root node, you have edges, then there are leaf nodes. Okay. Now, the most common usage of tree is searching operations, or where you want to organize the data. Okay. Where you want to organize the data, or you could say the searching, the searching operations that we have. So it kind of becomes easy with the help of trees. Okay. One second. The screen froze. 1 second. Just give me a moment. Actually, this screen froze.
Guys, it will take a minute or so. I believe there is some technical error. Oh, she's back.
1 second. Yeah, actually, the screen froze. I'm so sorry for that. Okay. So we were talking about different things, we were talking about the tree data structure, and I told you that it's a non-linear, data structure or a hierarchical data structure, because there is a hierarchy which is maintained. There is a parent node, then you have child nodes, the siblings, and so on. So there is a hierarchy as well. So it's a non-linear hierarchical data structure which consists of nodes which are connected by edges. Okay, so there are nodes and all the nodes, they are connected by edges. Fine. Now, the question comes is, why tree data structure is required, or why do we even need it? Why do we want to use it? Something like that. What do you think? Why do we need it? So, like other data structures that we have, like we talk about arrays, linked lists, stacks, and queues, they are all linear, right? They are linear. The data gets stored in contiguous memory locations, and structures that store data, kind of sequentially, one after the another. Now, in order to perform any operation in a linear data structure that we have, the time complexity, you might be aware of time and space complexity. So the time complexity, it increases. Okay. In a linear data structure, the time complexity will increase with the increase in the size of the data. Suppose you have 5, elements. Right now, the elements that you have is 5. The time complexity will be something less. But later on, when you are going to proceed in the program, the size increases. Okay, the size increases, you're changing it to something else, you're creating more arrays, and storing data into that. Now the time complexity will increase based on the number of inputs. Okay, but that is not an acceptable case in our today's world, right? No one wants to wait. I mean, like, I took a 2-second break and I got a chat over there. I can't hear you. Though I mentioned that, the screen froze. You see how, we are kind of living in an impatient world right now. No one wants to wait. If you're going to go to one website and that website hangs a lot, maybe hanging, why it hangs up a lot, or gets, gets like kind of, it froze up a lot. So maybe it takes much time to fetch a list of users or, services that you're kind of looking for. You'll, straight away say that the website, it's kind of like a dull website that I have gone to, and it's of like no good, because it's kind of makes you wait a lot, right? So you'll be like, it takes too much time to load, the DOM is not loading, the images are not loading up, it's taking too much time. So I would rather not prefer to go to that website anymore. Does that happen? Does that happen? So if a website is loading a lot, it's taking too much time to process, your information, you straight away say, "Arey, what is this website? I don't want to work on this again. They should have made something better," right? It happens. So in this world where we are so, conscious of our time and related to this computational work, it becomes really important that how much time an algorithm is taking to implement something, because no one want to even waste 1 millisecond of their time. There should be no lag when your product is running, when your website is running. So it should be kind of like a seamless situation. You click on a button, you just get something out of it. You don't want to wait for that to load up even, right? So these linear data structures, they kind of give you a limited functionality. Okay. They kind of give you a limited functionality. Now, tree data structures, they give you quicker and easier access to data, as it is a non-linear data structure. So there the searching and sorting, the searching, it becomes kind of, easy task. You might have not been aware of this fact that on our systems, the files are also arranged in a tree structure. हमारे system पे, on our system, laptops, desktops, wherever you are working, the files, the folders, right? The files, the folders, they are also arranged in this form, tree data structure. Can someone give me another example? Just think and give me another example. Where will you find tree data structure? Think, where will you find tree data structure? Somewhere else? I'm asking, in real world, can you think of a place, of a situation, of maybe some product, whatever you are using maybe, where the tree data structure is being implemented? Social media is tree data structure. Social media is more of a graph data structure. Okay, there also you have nodes and edges, but that is in a graph. That is a graph DS. What about a GPS? GPS is again graph. Education. Now you have to explain me, educational sector. Searching, yeah, searching is one point. There you're in real world. Educational sector, yes. One I told you that, that on our system, the files and folders, they are arranged in a tree data structure. The other could be, if you have done HTML and JS, you might be aware of DOM, document object model. Are you aware of that? DOM is also implemented in a tree data structure. Okay, there is a root node, there are child nodes, okay, there are edges. So DOM, HTML DOM is also a tree data structure. Sorting and searching. So like here in trees, we have one kind of tree which is called as binary search tree. It's a variation of binary tree, but that is for the usage comes in searching operations of it. Okay. Now sorting algorithms, they can also be there. Also the BST is used in that also for searching and sorting. Okay. So another would be any other area where you think it's implemented. Think about it. Okay. Think. And if you are saying educational sector, banking sector, let me know, how you are going to financial systems. Now, how it is arranged, how do you think that it's, applied over there? I won't say any answer is wrong because we kind of use a lot, different kind of data structures, but where in that you think it's applied? Gaming, computer graphics. Okay. Now I'll move you guys to a whiteboard. Okay. And then we are going to discuss about a few terminologies that we have. Do you see my whiteboard coming up? Now, there are a few terminologies in tree that we are going to discuss. Put it down. Okay. Now, let's consider an example. Maybe there is a tree which looks like this. You have edges connecting it like this. These, these things that you see in the circle, these are called nodes. Okay, nodes. So a node, you can say, is an entity. Okay, it's an entity that contains a key or a value. Okay, that it contains some values. It's an entity which contains some values. Like, whenever we kind of build up a node, for that, we have some values, right? 1, 2, 3, 4, that is some values. Now here in node also, okay, now what do we have is nodes are also of a few type. Like we have a root node, we have parent node, we have child nodes, we have leaf nodes. Okay. Now root node is the first one where you start from, that is your root node. Okay. It's the topmost node of a tree. Root node is the topmost node of a tree. So it is always the first node that you create, that you put while you are creating the tree, and you can access each element of the tree starting from the root node. Okay. Starting from the root node, you can access each element of the tree. From here, you can access each element. Okay. So this is your root node, the first or the topmost. Okay. Generally, it is the topmost. Then you have parent node. The parent of any node is the node which references the current node. Okay. So parent node means it is for any node means it's the one that references the current node. So who is the parent of 2? 1. Who is the parent of 3? 1. Who is the parent node of 4? 2. And for 5, it is again 2. Okay. So from where it or which node references it, that is a parent node. Then you have child nodes. Child nodes of a parent node are the nodes at which the parent node is pointing to. Okay, so this parent node is pointing to this node and to this node. So these become child nodes. Which ones are the leaf nodes? So leaf nodes are those nodes which do not have any child node, like 3, 5, and 4. They do not have any child nodes. So they are the leaf nodes now. What are the edges? So edges are the connections which connect two nodes together. Okay? Edges are those connections which connect two nodes together. What are the internal nodes? एक और nodes होते हैं which are called as internal nodes. What do you think will be the internal node? Internal nodes. Internal nodes are those nodes which have, a minimum of one child node. Okay, like 2. Here 2 is the internal node. It has child nodes. Okay. Or here if 3 had a node again. So 3 would have become, would have also been a internal node. Okay. Are you understanding this? Okay. Now comes the other things, which is height and depth. Okay. Now comes the next thing, which is height and depth. So what is height? So talking about the first thing, which is height of a node. Okay, for any node. Suppose making this example again, 1, 2, 3, 4, 5. Now, considering the thing which is height of a node over here, which means is the number of edges from the node to the deepest leaf. That means the longest path from a node to a leaf node. Okay. Height of a node means it's the longest path. from that node to the leaf node. So here, if I ask for the height of 2, that would be only 1. Okay, you only have one edge. So you count the edges. Okay, let's say you have more edges here. Okay. So height of the node will become of node 2, I'm asking. Height of node 2. Then would be this. Okay, so then it would be 3. So height of a node means the longest part from that node to a leaf node. Longest path जो है वो ये जा रहा है या यहाँ आ सकता है. ठीक है, so it is 3. ठीक है, that you have to think of. Then you have depth of a node. ठीक है, then you have depth of the node. ठीक है. So depth of the node means for any depth that you have. So if you are going to calculate the depth of this node, that means it is the number of edges from the root to that node. So if I ask you for the depth of 2, it is number of edges from this node to the root node. So number of edges means 1. Depth node of this node, depth of this node would be number of edges till the root node. So 1, 2, 3. For this, it would be 4 and so on. So that is the depth. Okay? Then height of a tree. If you want to calculate height of the tree, that means from the root node to the deepest node which is there, or the last, leaf node which is there. That is the height of the tree. So from the root node to the deepest node, okay, that is the height. So what is the height of this tree? 1, 2, 3, 4. Okay. This is your height of any tree. Now moving to the next thing. There are different kinds of trees. There are different kinds of trees or types of trees. You have binary tree. Today we are going to look into binary tree. Okay, binary tree. You have PST, which is binary search tree. You have ABL tree, B tree, B plus trees, and so on. Today we are going to discuss binary tree. Okay. Now to move to that, the first thing that you need to start with any kind of tree operation, the first thing that you have to remember is to create a node. Okay, so I'll tell you about how to create a node in Python. And we've also kind of traversals. There are traversals. What do we understand by traversal? What is traversal? Checking each and every node. Okay. Traversal means just to kind of move through the nodes, from one node to another node and so on, right? That means to visit each and every node. That is a traversal. So checking one was also fine, but basically traversal means this, okay? Now, if you have to implement, so whenever we create a tree, we need to traverse a tree, we need to visit, yes, follow, systematically go to each node. right? To print the tree elements out. So traversing means that you want to visit every node. Visiting every node, okay, in a tree. And every node in a tree is visited 3 times. So there are 3 types of traversals which come up. Okay. One is in order. Then you have preorder. And then you have postorder. I'm going to talk about each one of them in a bit. So let's move to the programming part now. I know you weren't able to look at my camera because I was writing on a whiteboard, that's why. Okay. Now, taking you guys to a text editor now. I hope it is coming up. Right? Now, the first thing is how to implement a tree in Python. So first you need to know how to implement a tree in Python, right? So to implement and to create a tree in Python, we first need to create a node class for each node. You know, you need to have a node class here. So let's create a node class node. And then here what we are going to do is node. What does it do? It represents a single node of your tree. Node class will have 3 variables. The left child, the second is the value that we have, and also a right child. Okay, the 3 things that we are going to have. Okay. And here we are going to pass self and data. Then the first that we are going to have is self. Self works like, if you're not aware of self works like to point to the current object. Okay. Just if you have done some other programming language like Java or something, so there we have this kind of with that functionality. Okay. So left equals to, right now you don't have anything inside it. Put it as none. Self dot right again as none, and self dot data equals to the data that we are going to pass. So this node, it represents the current, the single node in there. Okay. Now, if you want to initialize a tree, you're not going to see anything, the output, but I can tell you how to initialize a tree. So initializing a tree means you are going to create a variable that is going to, have this constructor call of node. So let's say the first that I have is root. Okay. And now here you're going to pass the data on. Like you can have 10. And then for, then for each left, right, you can add, different datas now. Okay, not much you have to do. Like you can do root dot left. How much you want to add? Okay, root dot left, you have node. Let's say we have 10, we can give some like 34. We have root dot right equals to node. We are calling it now. 9. You can put root dot right. Left lagana hai aapko over there. Then you can put node. And here you can give some other value. And then you have root dot right dot. And there you can put on the right hand side. I'm building on the right one. Okay. So node. Again, give a number over here. Okay. That's it. Now, when you're going to save it, you're obviously not going to get anything. Okay. Because you're not printing anything out. But let me show you how it comes up. 1 second. Okay. So the output tree, I'll show you how the output tree will be built up. So to build up the output tree, you'll have 10 as the root node. Then you have put 34 on the left, and on the right we have put 89. Okay. With the 89, we have given left and right. So on left we have 45 and then 50. It would be something like this in this format. Okay. It would be in this format. Fine. So this is something that we've built. So if you create an object of the class node, there is the init constructor is called, and all the variables which are inside that constructor, they get initialized, right? The root, it holds the root node of the tree and has a value of 10 that we have given right now. Then we insert a left and the right child, and then so on. We build up the tree, from left, right, and left, right. Okay. You can insert more if you want. So you can insert any number of nodes we want inside a tree, depending upon the type of tree that we are created. Okay. Now coming to traversal part. So when we talk about in-order traversal, okay, so in this case, we first visit in the in-order, like we have in-order. Okay. So with in-order, what we do, or I'll write here. Like for in-order that we have. So what is an in-order traversal? So in some cases, what we do is we first visit the left child. We first visit the left child. Okay. You perform recursion on it. Recursion is performed. Okay. Then we visit the same node for the second time to print that node. And it is further followed by the parent node and then followed by the recursion on the right node. So in order, something like left child, parent, and then right. Okay, so from left, parent, right. Then it finishes off, it goes up, left, parent, right, and so on. Okay. So what would be the function for in order look like? What do you think? How will it look like? Anyone who wants to attempt? Or not the function, if you can give me the, kind of an algo for it. What do you think? Will it look like? Anyone who wants to attempt? No? Okay, let me take you then. So for in order, what am I going to do is I'm going to create a separate function for it. Okay. Now here we pass the root. I mean, like from where you want to start it, right? If you are on the root, then what you have to do is you have to traverse left. Okay. Traverse left. That means you have to do an recursion over here. In order. And then this should be root dot left. Okay. Why I put semicolon. Okay, root dot left. Then you have to traverse the root. Traverse root. Then here, again, this would be for the root. Print kara denge. We are going to print it. Str root dot whatever it is data. Okay. Then plus. Then you can give show like this and end. Okay. And here like this. Come on, and then you have to perform recursion again on the left hand side, okay, when you are traversing, sorry, right. So here again, you're going to do in order root dot right. Okay, like this. Fine. So this is something that you'll see. And if you want to check it, let's check. Let's run this and check. So we have created root, left, right, and so on. Now let's do the printing of it. So let's print. I'm going to write print, and here I'm going to do in order traversal. Okay, and you just call the method in order with root. Do you see the in order traversal? 34, then it has got 10, then it moved to this subtree and it kind of traversed the left hand side. There are no more elements after it, so then it goes to the root and then back to the right hand side. So this is the in order traversal. Okay, now if you have to do the next one, okay, the next one is your pre-order, let's say. So now you have to do the pre-order traversal. So you have to pass a route over there. Yes, because you have to tell, from where to start. Okay. So from where to start, that has to be told, so that you are going to start from root. But now the thing is that in your pre-order, you start from root, you go to left and then to right. Okay. This is the order for pre-order. So this is again very simple, not much. I'm just going to make a small change like this. And this is now your pre-order. Then you traverse left and then you traverse right. Okay. Pre-order. Let's call it and see. Okay, so we've got pre-order traversal over here. Fine. Both of them working fine for me, right? Pre-order and in order. Now you have post-order. Now it's kind of, now what is post-order? So there in post-order, you traverse left, right, and then root. Okay. So in post-orders, you see the implementation in, Python is so simple. Not much that you are doing right now. Okay, not much. The implementation is so simple in Python. So in post order, you go left, you go right, and then you go root. Okay. And here, this should be post order. This should be again post order. Coming to here, do your post order traversal. Okay, now we've got the post order, pre-order, and the in order, right? So you wanted to come on the next line. Please give. Okay. So this is about the traversal of it. This is how we can traverse. Now, if you have, the next that, kind of we are running out of time, but then just to give you an idea of a binary tree. What's a binary tree? Anyone? What's a binary tree? So binary tree is a tree data structure in which each parent node can have at most 2 children. Okay, not more than that. At most 2 children. And each node of a binary tree, you see, consists of 3 items, as you know what we have done over here. This is a binary only. Okay. So each node of a binary tree consists of 3 items, data item that we see, the left and the right child. Okay. The implementation of it is, kind of this only. And this is a binary tree that we've made, at most two children with right, left. Okay. And it is kind of used a lot. Binary tree implementations are a lot. There are different kinds of binary tree, like you have a full binary tree. Now, what's a full binary tree? In which each node, the internal node which is there, it has either 2 children or no children. So complete binary, or we say full binary, is one where you have 2 children or no children. It cannot be like that, you can have 1 child or no. No, you cannot. You can have only 2 children. A perfect binary tree is a type of binary in which every internal node will have exactly 2 child nodes. Okay, that is a perfect binary tree. Every internal node. Okay. So there are a few others. The implementation of a binary tree, it looks like this only, that we've created for a class node, and we have left, right, and a data. Okay. The traversal is again the same for each one of it, and the same kind of goes. So this is your binary tree implementation that we've seen. Okay. Have you understood till here? Yes, that's so cool. Now talking about, as we are trying, coming to the end of it now, some more implementations, or you could say applications of, let's discuss about trees. Okay. We have talked about that it's used in sorting and searching with the help of BST, and also if you know about another data structure, which is called as heap data structure. Have you heard of heap data structure? So heap data structure is also a kind of a tree, and it's most widely used in a sorting technique which is called as heap sort. Okay. So a modified version of trees is also there, which is called as, it's again pronounced as tree, but it's written as TRIE. Okay. So it's a modified version of trees. Okay. So most popular databases which are there, it makes use of trees. Like it makes use of B trees which are there, okay, to store the data. Also the compilers, okay, the compilers that we have, it also makes use of tree data structure to validate the syntax of every program, whatever line of code you are writing. So what is the work of compiler? It checks, it compiles a code, so that checking is done through tree data structure. Okay, so there are many implementation of trees basically, but that is, only something that is you're going to learn one by one. Okay. Now, to sum up, or to kind of, bring it to the end, you have, the application, or towards the, concluding it, what would you conclude from the, tree data structure? That is it the most useful kind of data structure that we have? Using trees in Python, as I can say, as you look at the code right now, it's so compact, right? Is it compact? The same code, I can guarantee you, if you go and write in other programming language, let's say Java, it's going to take a lot of lines of code. Okay? Yes, it does take a lot of lines of code, but in Python, the implementation of trees or any other data structure is actually fun and concise, compact. These trees, the DS, it's used in different software and applications according to the need, but it's most widely used again, next to graphs. A strong grip on, the tree data structures, it can be very beneficial, and not just tree data structure. I'll talk about all the data structures. Data structure alone is a very important concept. It's a very important topic, which is required by each and every programmer to learn and to master. Okay. So it's going to be very beneficial for if you're just starting your career, so in your interview process, but later on, as you're going to proceed in your career and you are the one, you're the developer, you're into development, it is going to come, I would say, in handy, but to a much greater extent, because without it, there is no implementation of any sort that you'll be able to do. Every now and then you'll be applying one or the other data structure, but the need to identify which data structure would be, feasible in what situation, that only comes with sheer, I could say, expertise and experience and also understanding. Right. So until you are through and through and you are able to implement each and everything, each and every data structure, and talking about, let's say, trees, data structure won't be helpful. So you need to understand, where this is used. Only then it is going to benefit. Okay. So applications are really important to understand where it is applied and what kind of, data that I have and how to even, process it. That is of most importance. After understanding the principles of a tree, it is important that you have to practice. So now you've done this. Now, if I give you a question and I ask you, stop sharing, and I'll say that, maybe after the session, what you do, you implement this. Only with the implementation, you will be able to understand, right? So it is of utmost importance that whatever you, learn, and if you are here to learn and to, talk about and gain some knowledge about the tree data structure, that you implement this, practice as much as you can, because without it, it's not going to take you anywhere. Okay. So it's actually very important. Your dictionaries in Python, everything is implemented through, kind of with the help of tree. So tree structures, they are very purposeful and very powerful data structure that have many applications, as we've seen and talked about, and use cases in web development, you see. Okay. So our aim today was to clear up some of the fag around them that, the beginner and the junior developers, they usually experience, the ones, those who are just starting out. With trees, we think, oh God, this is so tough, I cannot do it. But when you saw that it was so easy to implement it, as normal binary tree, it was so easy, it was just keeping in mind that, okay, this is the traversal, this is what I have to do. With Python, it became quite simple for us, right? So when learning a new concept, it is very beneficial to learn about the concrete as well as the real world applications of it. Only then you can relate, okay, where it is used. Okay. It is important to have a knowledge of how to interact with these various representations, with these various data structures. Okay. When you are going to encounter them, when you are going to come up, when you are going to have that problem in hand, that which data structure to implement. Is tree okay over here? Because tree and graphs both are, non-linear. So you've said that, GPS, it makes use of trees. I think you also told me about some other thing where I said no graph is used. Like airline systems, I would say that is again a graph. Road interconnections, that is also graph. So you have to identify, where to use what kind of data structure to store and organize the data well. Okay. So that's it from my end. If you have questions, let's address those. BST, binary tree, BST, B trees, these are different. They're not same, Girish. You start from binary tree, then you move on to different trees, which is AVL, B trees, B plus trees. ठीक है, binary search tree, it's an implementation of binary, but it is used for searching.
All right. Thank you so much, Swati, for taking up that session. I think it went really well. Now, guys, what we'll do is we'll just go ahead and run a poll just to see, if you want to know more about the program. You will have a poll which is reflect on your screen in just few seconds, which says, do you want to know more about our programs? If you select a yes, then somebody from our team will get in touch with you and counsel you on the same. So if you want to know more how you can, learn Python, how you can build career in IT. So we have our team of experienced counselors who will get in touch with you and guide you about the process. This poll is going to end in just a few seconds. Kindly let us know if you want us to get in touch with you in regards to a program. Okay, the poll will end soon. All right, thank you so much, for letting us know. Swati, do you have something to add on this?
No, I think I'm good.
All right, perfect. So before we end the session, I would like to inform you that Unikaksha, have various programs which can help you learn the latest technology that is required by the IT industry. So in case if you're looking forward to make your career in IT, just get in touch with us, explore our website, look at the options, look at the programs that we offer, and accordingly give us a call so that we can guide you further. We have many programs with also come with 100% job guarantee. I mean, and various payment options as well, like flexible payment option of paying after the placement as well. Right. So we have various programs, various options. Kindly get in touch with us so that we can help you build your career in IT sector. All right, I think that is all from our end, as we see that we've answered all the questions and there are no pending questions in Q&A. We'll put this session to an end. Thank you so very much for joining us on a Saturday morning and, being such a lovely audience throughout the session. Thank you so much.